In this video, we want to look at evaluating a limit by using a table. Because we'll evaluate the function at several different x values, we can use the table feature of our calculator to help make that process easier for us. Okay, let's just take a quick look at what we'll be evaluating. We're looking for the limit of x minus 2 over x squared minus 3x plus 2 as x approaches 2. And so we've already set up our table to kind of look at x values that will be getting closer and closer and closer to 2. So on the left, or from below 2, we're getting closer by looking at 1.9, 1.99, 1.999. And then from the right, we're starting at 2.1, and we get closer by coming to 2.01, and even closer by coming to 2.001. So we want to set up our calculator so that it will evaluate the function at all of these values for us. So let's take a look at how we'll do that. The first thing I'm going to do on my calculator is to put the function in my y equals list. And of course, we're going to need to make sure that we follow the order of operations. Our function was a rational expression. We have a polynomial in our numerator and a polynomial in our denominator. We need to make sure that we use parentheses to enclose the entire numerator and enclose the entire denominator. Okay, so first I'm going to hit y equals. That takes me to my y equals list where I can put my function in. I'm going to use left parentheses and x minus 2 and close it with the right parenthesis. Okay, divided by left parenthesis again, x squared minus 3x plus 2. And we're going to close it with the right parenthesis. So I have entirely enclosed my denominator, and if we arrow back over, you can see that I've entirely enclosed my numerator. Okay, so the next thing we're going to do is set up our table to take the values that we want it to take. So I'm going to go to Second and Table Set. And right now it's set on automatic, and it's set to start at a value of 0 and make increments of 1. Okay, that's not what we want. Okay, we don't want to start at that particular value, and we don't want our increments as we approach 2 to be the same size. We need to get closer and closer and closer and closer. So instead of looking at auto, we need to look at ask. Okay, so I'm going to arrow down to the line where it talks about the independent variable, which is my x variable, and I'm going to arrow over to ask, hit enter, and then now ask is selected. So instead of it automatically setting up values for us, it's going to wait until we specify values. If you were looking in this area a little bit earlier, and I'll go back so that you can see the difference. When it was set on auto, you could see it started at 0 and it was incrementing the values by 1. But we don't want that. We're going to put it on ask. And so right now it's waiting for us to tell it what the values are. So we've got the table set up the way that we want to use it. Now we're going to actually go to the table, which is accessible through the graph key. So I'm going to use Second Table, and then I can start putting in the x values. So we're going to look at 1.9, 1.99, and 1.999. All right, and we can stop right here for now because we are looking at the values from or as x approaches from the left. We were at 1.9, we got closer by coming to 1.99, and even closer by taking a smaller increment but getting closer still. And so we're at 1.999. And so what does the function do at that point? We can see that the function values are getting closer to 1. Okay, we're going to do the same thing, except this time we're going to look at it from the right. I'm going to put a 2 in here just so that we kind of see the value that we're trying to approach. And then we're going to put in 2.001, 2.01, and 2.1. So we're getting closer to 2 from the right. Okay, and if you look at the function values, you see that it's getting closer and closer and closer to 1. We were able to quickly evaluate the function at multiple values. We can look at the behavior of the function from both the left and the right and use that information to help us determine what the limit would be. And in this case, from both the left and the right, we see that the function approaches a value of 1 as x gets closer or approaches 2.